Well, okay. First of all, I do feel that we just need to just tie off a little bit on last week.
Okay.
It so amazingly, in a rant about how I was mispronouncing words and everything I knew was wrong, I mispronounced hagiography, which Dan, you corrected me on, and then I ordered you to get out. So I'm sorry about that because your correction was in fact correct. So it was just a bridge too far for me on last Monday. So anyway, I just wanted to, Dan, I wanted to formally apologize and thank you for correcting my grievous mispronunciation of hagiography.
Good. By popular demand, this can be like a standing weekly apologies for words pronounced wrong in the last week.
Yeah, exactly. That's right. Um, yeah. Well, I just love the fact that you were like, "Who cares?" and then immediately corrected me like moments later. So it's like, well, who cares? Clearly, there's a fine line between the policing mind and the criminal mind in this particular dimension because you obviously care. So I care too. So we all care. But that was a lot of fun last week. That was super interesting. So the pronunciations aside, the reliving deck was really interesting. So Adam, I've been excited to see how many folks are really interested in this topic, which is
very fired up to see the response. I don't know about you, but about Sunday mornings, I started thinking about if we haven't already telegraphed what we're talking about, I start getting a little itchy. And on this one in particular, because often we go dumpster diving into your recent tweets to see what went well.
Uh-oh.
And no, I don't. I mean, I nothing had blipped on the radar, so I was kind of wondering what we were going to talk about. But then, you had this great kind of out of the blue comment that I think you received.
Yeah, I mean, not only out of the blue. I mean, a DM, and I'll definitely anonymize it here. But are your DMs open actually, Adam?
Yes. Any follow-up question? Yes.
No, I'm
yes,
just curious,
open.
like how many people have. I have open DMs, and to me, it's actually really important because yes, there is some amount of spam, but there's also like a lot of people who have interesting thoughts that DM it to me.
Absolutely, and I mean, the amount of spam I get is very minimal, and the amount of
I am getting a lot of spam. I get a lot of like cryptocurrency spam.
Oh,
do you not get any of this?
No, well, maybe I don't check my. They have the two folders. The like we think it's spam and we think it's not spam, and I don't check the folders very often.
Why must I stare into the sun at the one that we think is spam?
The one I get a lot is I get added to some group of 25 random people.
That's all cryptocurrency spam.
Oh, okay. Good to know.
So, anyway, ignore all that. But so so someone I didn't know came into my DMs and asked a really interesting question, which is what has prompted this discussion. And so the reason I'm writing to you is to ask you for a piece of advice on how to do a transition from where I am in the tech field to a full-time systems programmer. A bit of context, I come from a user space background. I've been doing that for 15 plus years. I tend to gravitate towards hardware-related subjects. And because of that, I've gone through a bunch of different things, solutions architecture, operations in the last 5 to 10 years, and I've really enjoyed that. I've taken various courses on Linux kernel development, and I really have fallen in love with that. And I've been really trying to invest my free time in understanding this stuff and bridging the gap between my software knowledge and hardware knowledge, such as I've been working on a hobbyist OS, and I've been blogging about it. I've been trying to contribute to the Linux kernel. My problem is that I am having a hard time breaking in. I'm not getting interviews at the HR level, and I try to ask for advice for people, and sometimes I get some good insights, but a lot of them just try to talk me out of this and tell me that this is not worth doing. So I don't know how to proceed, and I'm hoping that me in a sense, can help me proceed. And I was thinking this is a great. I want to hear from everybody on this because I've got my own ideas, but I think a lot of people are going to have their ideas on how to break into systems programming. And I think for starters, Adam, I feel we should define systems programming.
Yes, we definitely should. Why don't you go first? Because as I was writing it down, gosh, it is kind of it's easy to talk about characteristics and it's hard to hard for me to give a succinct definition.
I feel like I have the same problem actually with software. Just defining software. Have you done this? Have you ever tried to I'm going to come up with a concrete definition of software right now? Have you ever done this?
No.
It does not go well. Basically, it's really hard to come up with a definition of software such that Euclid wasn't writing it.
I was just thinking that. Just thinking like that. That the Greeks weren't writing definitions of algorithms, and that product managers through the specs aren't programming.
I mean, any definition of software that relies on a definition of hardware is just going to get. I mean, it's just too easy to make. What if we annihilate all the hardware? All the software no longer exists. Like that doesn't make any sense. So did because you and I both know Mike Olson at Cloudera.
Yeah.
So I went to Cloudera in like super early days. This is when we were at Fishworks. This would have been like 2007, 2008. Mm-hmm. Because we knew like Jeff Hammerbacher was there, and we knew a couple of folks. Yeah. And Amr was there, a couple of folks that were there. And I think I went by the office, and there were like 5 people there and that worked at Cloudera. And
this is in the old Fry's Electronics.
This was in Burlingame.
Oh, okay.
And I feel that we need Mike here. I feel that they went through like 6 offices in like 4 months. So this was a very brief stop. It was a super weird office. I can definitely see why it was like it kind of defies description. It was like the set of WKRP. That is not. That is. Right. Yeah, you know what? That's not a clarifying comment. But so a super weird office, and I had just come from this interesting interview with Arthur Whitney that had me questioning everything, and that was like my opener was like, what is software? And we spent like 45 minutes trying to define software. And any definition of software, it was too easy to refute, to your point about systems, to the point where like Mike took me aside and he's like, are you high right now? Are you on drugs? Like, what are you, have you, like, what are you doing? Why are you here? What is happening right now?
Right. Is it 2 a.m.?
Is it 2 a.m.?
And you're very high?
Are you extraordinarily high in my office at like 2 p.m. on a Tuesday? Like, get out of here. Like, let these guys, anyway. So it's like, no, I'm high on life, Mike. I'm just high on software right now. High as a kite. But okay, so systems. So with the kind of the caveat that I can't even define software, let alone systems. I do think that when we talk about systems, we are talking about software interactions. We're talking about software that runs other software is my most concise definition. Software that is responsible for the creation of other software, runs other software, executes other software, debugs other software, that the interaction is not with an end user, but with that software interaction. How bad is that?
Yeah, I see. It's better than what I had, because the not as good definition that I was monkeying with was anything that's not really sitting at the top of the stack, and that's really insufficient, which is why I like yours better, because my definition includes lots of libraries and frameworks, which I don't know, felt a little squishier, but yours, where it has more to do with the execution of other software, is interesting.
So I think it'd be inclusive of a lot of those things.
Is LS systems programming?
Yeah, for sure.
Yes.
Yeah.
Yes.
Yeah, I think so.
What about Xterm?
Are you high right now, Josh? Are you on drugs? Are you coming
no,
into the space high?
I feel like this is. Well, I'm in Australia.
There you go.
Yeah, there we go.
I don't know if that counts.
So I will say yes to Xterm, but I would say that like it's very easy, because we don't feel good about these definitions, to go from into suddenly is Minecraft systems programming, and feeling like compelled to say yes to that.
Is a web browser systems programming?
Oh, see, that's what I'm saying. So,
man.
Yeah, because like you got like clearly you have your JavaScript engine in there.
I'm here to ruin the space.
Yeah. No, exactly. Right. So I know we're like going into CSS's systems programming. I understand that's what you're getting us towards.
It totally is, though.
Ooh, I mean,
Oh, okay.
I feel like systems
let's
programming is an approach as much as anything else.
Yeah. I agree. So
really?
Let's define it by some of its attributes, Adam, because you were saying earlier that like
Yes.
I know some of the attributes about it, because I definitely feel like I have got a handle on some of these amorphous attributes. What are some of the attributes you think about system software?
Well, I mean, I'm embarrassed that what I kept on coming up with was related to oxide values, and in particular, rigor and curiosity. And I think maybe less in terms of systems programming, but more in terms of systems programming. Like the mindset of the author, and I think that curiosity about the systems below and above you, and about kind of understanding the nuances of those, and then rigor in terms of thinking through, not just the happy path.
Yeah.
But I think one of the characteristics of systems programming is thinking about all the ways that things can go wrong, and handling those in ways that are comprehensible.
Yeah, that's a very good point. Where like software gets actually a lot harder when our expectations are really high for it. When we actually expect the software to work all the time and not just kind of seem to work in a lab, there's a bunch of actually really hard problems that we need to go solve. So, I like that. I also think that like system software, and you're just actually maybe a more positive kind of amorphous feeling than I've got. System software is hard to love. It's hard to appreciate because I feel like, we talk about these systems demos. We like to give systems demos inside of Oxide, and to the untrained or even trained eye, perhaps, they might look very unimpressive. To see a machine boot, to see a packet go over the network, to see these things that are seemingly simple but are fiendishly complicated. And I feel like that's kind of getting into your curiosity point too, Adam, where like in order to be successful in systems programming, you constantly need to be kind of pulling at these abstractions, because the abstractions are actually trying to seal you off. The abstractions are trying to get you to not think about them. And yet so much of system software is understanding the abstractions, understanding the interactions across the abstractions, evolving the abstractions. It's like you can't be content you really do have to understand that you are at the way you described it, like you've got to understand the software below you and above you.
Yeah.
Is this a big mess at this point? Have we like?
Well, I mean, I kept on coming to like the Justice Potter Stewart line. You know it when you see it.
Yeah.
And I'm not sure that everyone is going to agree on any particular body of software being system software or not. But I think that the mindset and the approach of robustness and of sort of complexity and perhaps constraint, and this is something we've talked about on a bunch of previous spaces, where I think perhaps systems programming is also defined by the constraints around you, that there are kind of spaces you need to fit into, or compatibility you need to consider above.
Yeah, interesting. Is hardware-facing software always system software?
Hardware-facing software. That is to say, software that directly
is directly on the metal, whether it is in a privileged mode or not. Whether it is, I feel that's a trick question.
Well, yeah, I mean, it's so tough too, because like first of all, I mean, I was thinking about the privileged mode, because I 20 years ago, 25 years ago, when we were starting, there was sort of this clarity of, is the priv bit set or not? And now, like, what does that even mean? Like, you're sitting in some virtualization layer, and it's like, what priv bit are you even talking
the priv bit is a lie. The priv bit is, yeah.
Right.
It's right. You're talking to virtual hardware.
And it's like, well, okay, if I'm talking to hardware, it's like, well, does that mean that anything that is compiled into an ELF binary is systems programming? Because like that's sort of talking to hardware, I guess, right? Like machine code instructions.
Yeah, and I feel that like also going back, I'm just trying to go back to I like your rigor and curiosity point. Because system software, it's hard, right? Can we agree on that? It is hard.
I mean, yes, I think so.
Right.
I mean, it's hard for me.
As a subset of all software is hard. I mean,
right. I mean, I feel that like it's hard in a particular way. Like numerical programming, I think, is extraordinarily hard in a different way. System software, I mean, is that?
No, I think that's absolutely right, and I think that in the same way that like user interface programming is hard.
It's really hard.
And I think in the same way that I mean, you probably have this experience with user interface programming and with systems programming, where to a person who is incurious or kind of, not adept, like there are, I've seen engineers produce user interfaces where it's like, things aren't right and they kind of don't see it. And I think in the same way, I've seen people produce system software which fails in a bunch of ways, and until you point it out, it's hard for them to see it. So I think that it's a skill certainly that can be taught, like all these others, but hard in ways that is differentiated, and where folks have different levels of interest in getting into those details.
Yeah,
I think this stuff can really be taught. I thought about.
Hey, Dan, you're very faint.
Is this better?
A little bit, yeah.
Okay. What I was saying is I'm not sure that user interface stuff can really be taught. Or if it can be taught, it's taught in the same way that art is taught. I've often thought that if somebody said to me, "Hey, Dan, go write user interface stuff," I would probably fail miserably. Not because I wouldn't try, but rather because I just don't think that I have either the aesthetic or artistic ability to create a user interface that's truly good. You know what I mean?
And I do think, yeah, Dan, I do know what you mean. And I kind of think that, but in system software, we do create a lot of interfaces, but that we are often creating them for effectively ourselves or our doppelgangers, so it's easier for us to kind of intuit about the abstraction to create, I think, the interface to create.
I think both of those areas have a strong requirement for taste to produce good artifacts.
But I think there's a critical difference that Bryan hit on, which is that we create those interfaces, but we do it for people like us, right? Like other systems people. And let's be honest, there are a lot of interfaces that were designed by people with exceptional taste in, say, the 1970s or 80s that really haven't changed very much. Look at the read system call, for example. It takes 3 arguments. It takes a file descriptor, a pointer, and a length of a buffer. That was brilliant at the time, but you kind of how do you improve on that?
Yeah. So, okay. So in terms of, I mean, I don't know if we've I don't know if
well, certainly no answers there, right?
Yeah,
but
exactly.
I think in terms of some of the characteristics that the person who DM'd you was talking about, they're probably talking about things like embedded programming, like kernel programming, or building compilers or virtual machines, things of that sort, I'd imagine.
Yes. And I think that to me, for whatever reason, I guess it's so let's talk about actually how we got interested in this. Because I feel that because system software it's hidden from view, right? I think that this is I do feel that one of the attributes of it is hard to appreciate. You need to get kind of into it to really understand how complicated these things are. And I feel like there's this moment in one's education, be it formal or informal, where you realize holy God, I can't believe anything works at all. I can't believe that when I sit here in a prompt and get a directory listing, the amount of complexity that's happening, every time pitch perfect to deliver that. I just feel like that there's got to be that kind of a moment where one says that is either gives you just a pounding headache and you're I never want to think about this again. Or I think, Adam, to your kind of curiosity and rigor point, you think to yourself wow, that's super interesting. I actually really, I want to dig in. I bet there's a lot of other stuff I don't know, and kind of taking you down the rabbit hole. I feel like, is that a fair common theme about how people got into this?
Can I say that I remember the Systems We Love talk on YouTube that said, "What happens when you exit with 0?" Do I remember the title correctly? And when I saw that talk, I was like, oh, okay, so a lot of things can go wrong. How is this actually still working? 1. And 2, apparently, the person who was showing it was from Joyent. I remember that correct, right? And they were showing it on the SmartOS code base. And how much legacy is actually in there for all of these years. Like Dan said, things don't ever change. That's also fascinating. But what's also more fascinating is well, not fa- no, well, actually, I do have a question about the fascination on that part. Is since you guys been in this thing for 25 years, has it actually changed like a lot, or only in the hardware, the privilege stuff, or only the virtualization, or only abstractions? Is there an actual major change that has happened or will happen?
I mean, Bryan, I don't know if we're going to have to say it at the same time,
Yeah.
but I assume we're both thinking Rust.
Yeah.
Damn.
Yeah. I mean, yes. I think Rust is. I do think Rust is a very big deal. And I think that the Rust is also a reflection of a lot of big changes. I think that systems programming has changed a lot. I think that one of the major ways that it's changed, this is not a deep thought, but Rust does reflect this as well. That whole open source thing is a really good idea, as it turns out. And this kind of gets to kind of a point that you were making about these, these kind of old software systems that are still functional. I mean, to me, another light that went on in system software was I was accustomed to, when I was just kind of writing my own programs, that kind of everything was broken all the time. And as you get deeper and deeper into system software, you realize like, oh, wow, there's a lot of software down here that actually has been working correctly, or working as is, I guess, in some cases, for a really, really, really long time. And that kind of, Adam, to your point about rigor, kind of changed my own expectations for the kind of software that I could write, where I thought, like, wait a minute, we can actually write perfect software. Why not? And I feel that there's a lot of software in C that is going to stand a long test of time. But C, as we all know, has got some really serious shortcomings that make it hard to create, or harder, I think, to create truly persistent artifacts than we get in Rust.
So just a quick diversion on that, Bryan. You remember when I rewrote NoHup, Solaris' utility?
Yes.
Okay. So I rewrote NoHup.
Do you want to explain NoHup a little bit?
So NoHup is a command that you use to background a process that you've run interactively. So the canonical use case is like I run a long running build. I forgot to put it under NoHup, or I forgot to run it in a screen session, and then I need to go home for the night, and I don't want to pack up my laptop and kill the session. So I run NoHup -p to background it, and that was the utility that I added.
And hup being SIG-hup, it's the hang-up signal that dates for. I mean, I think it is Signal 1, right? It dates from the very dawn of Unix for sure.
And this utility I rewrote was written by Joseph Asana in, I mean, just the first moments after the Big Bang of Unix.
Before the flood, for sure.
Right. So now we're talking like 70s, and I just want to point out, Bryan, that it has been 20 years since I did that.
Yeah.
Just to show how goddamn old we are and how durable this software is.
Yeah. Tom, did you know? I should get Tom in here. I don't know if Tom knew Joseph Asana, but Joseph Asana died tragically. He died young.
In a car crash, as I recall.
Car crash or a heart attack?
Heart attack. Asana died of a heart attack.
No, there you go. We were waiting for. All right, hagiography.
In 77.
Heart attack. In 77, yeah. Did you know him, Tom?
Yeah, he was there the summer I worked, and he died that fall, I think.
Oh, wow. But so he died with a lot of software that people were not able to rewrite. So Adam, I recall joking with you that you're going to be haunted by Asana's ghost.
Yeah, and that has borne out, and it's been terrible for the last 20 years.
Oh, really? Does he visit you 3 times a night? Did you get is it like past, present, future? I mean, what's it?
Oh, hey, Joe. Yeah, right.
Oh, it's a little bit like a Casper the Friendly Ghost kind of.
Got it. Time to go to bed, right? So Bryan, you in terms of your own entry into systems programming, you were writing as a high school student. You were writing a bunch of games, as I recall.
I was doing a bunch of just bullshit. I mean, I feel like a lot of people, I thought I understood computer science when I didn't.
Well, but you were writing some code, and you went to college thinking that you were maybe going to be an economics major.
I was going to be an economics major. Yes.
Okay. So so then what opened your eyes?
Well, I think that the understanding that there was an actual discipline behind computer science was eye-opening. Number one, it's like, oh my God, this is actually like real. There's like actually you can like reason about algorithms, and I thought that was amazing. And we can actually, it's not just programming. There's actually computer science. So that was kind of like. Also, I flunked my first economics exam, which also helped.
That really helps. Right?
I had a C me written on top of I had convinced my roommate to take this very quantitative intensive micro course, and I had never done partial differential equations, so I was like learning partial differential equations on the fly as an idiot 18-year-old or whatever. And I just remember getting the exam back, and this guy in the kind of very old school fashion plotted in chalk all of the scores on the exam. And all of them are like clustering in kind of the 90s and 80s, and then maybe just one in the 70s, and maybe like one in the 60s. And then there were two little dots next to one another at like 33. And that was me and my roommate who had gotten a different 33% of the exam correct. Like we definitely did not. I mean, we had gotten the exact same score, but like between us, if we combined our knowledge, we would get a D- on that exam, basically. So that helps. Don't underestimate the power of the universe to kind of point you in one direction.
Nice.
But so that was kind of realization number one. I think realization number two, though, was when, and I feel like I got very lucky. This happened all very young. I got a very clear sense of what I wanted to go do at a very young age. And I think this is very unusual. But taking an operating systems course, for me, and this is why I do think that like formal pedagogy is actually important, even if you do it online or in an informal capacity, Ben Eater or what have you. When you kind of sit down and are forced to do a course and a lab intensive course, this is just this moment of like, oh my God, I know nothing. I know absolutely nothing. I thought I had some idea about the way computers work, and I have no idea how computers work. And no idea how system software works. And little did I know that feeling would typify me for the next 30 years. Because I feel like at Oxide, I'm always like, well, it looks like I picked the wrong day to know how computers work, because I'm learning about something, totally some other aspect that I do not know at all. And I wonder how I've gotten this far not understanding this dimension of how computers work or how system software works. So that for me was the big light going on of that's why I like your curiosity point, because it did actually really arouse my curiosity of, wow, I knew so little, and now I want to learn so much more, and I want to affect these abstractions. And for me, the ultimate system software demo is the linker assignment we did in that course, where you wrote a linker. Because of course, and that to me is like, what do you mean you write a linker? It's like, well, a linker is just a program. It just like reads things off of the disk and like does some things into memory and then like jumps to an address. But that was just like, I mean, I felt like von Neumann was sitting in my lap, like whispering into my ear. I felt like it was just like, it was hot and heavy romance with Johnny von Neumann and this programming computer.
Lovely. That's a great image.
Yeah, maybe that was a little too much. I got
I'm here for it.
Johnny von Neumann biting on my earlobe might be a little bit too much. But
that movie with the pottery.
Yeah, like Ghost. That's exactly what it was. It was like Ghost, but Patrick Swayze was being played by John von Neumann. Yeah, that's what it is. And I was Demi Moore, and the pottery was a linker. There we go. Well, thanks, Josh. I think we cleared that up. Nailed it.
I'm here to help.
Yeah, there you go. So that to me, and that was like this big revelation. And then there were a couple other revelations that came out of that. Of like, I decided I thought I was going to go to PhD, and then I actually wanted to go do industrial system software. But the one thing that I heard that I think a lot of people have heard is nobody does this. Like you shouldn't. There is no there. Like there's no career for you in system software. And I feel that this comes out of the fact that system software is so hidden that the people that work on it are often hidden. And so people don't appreciate, and it's like, no, like this is really important stuff, and a lot of people do work on it. So,
well, that's relative. I mean, it took me something like 20 years to gently maneuver the entry vehicle to the point where I was actually writing system software, like of the kind that I wanted to.
So Dan, talk about your story a little bit, because you got definitely an unorthodox story.
Yeah, I mean, I got really interested in operating systems when I was in high school. And in large part because I wanted to understand how the system worked. And I like really what I wanted to understand was this notion of multiprocessing. And, you know, on a uniprocessor system, like, what does that mean? How does the operating system do that? And, you know, eventually somebody told me, well, there's a clock. And like, you know, that clock ticks every so often. And on a clock tick, you get an interrupt and you do something. And I was like, oh, wow. You know, that was a huge revelation. I was like, well, how do you do a context switch? And then eventually I sat down and I wrote a coroutine jump routine in assembly language for 68,000. And I was like, oh, that's how you do it. You know, and then I was like, well, how do you switch from one process to another? It's like, well, you know, really, it turns out in the kernel, there's effectively a thread which represents every process, and you trap into the kernel and do something, and then you do a context switch from one thread to another, and now you're running in the kernel, and now you switch an address space. It's like, well, how does that work? Because I was in a different address space. It's like, well, the kernel is mapped into every address space, every process, and it was like, oh, okay, you know, so I kind of got these little inklings of how this stuff worked, and that to me was very compelling, and I was like, well, I want to do this, but at the time where I was really interested in working on that, you know, or by the time I was in a position where I was, you know, okay, this is really what I want to do, it was so commodified, especially with Linux and open source, that in many cases, people were just like, no, we're not going to work on that because that's not interesting. And we don't generate a lot of revenue for that. And so I think if you look at the industry writ large, you have, you know, many hundreds of thousands, if not millions of programmers who are working on all sorts of things, but they're not doing that sort of low, you know, like there are people who are doing that low level software development, but their numbers are much, much smaller. It's a tiny fraction of a percent of the total industry.
And then, but Dan, you were doing all that in high school? Like all the 68K context switching code and so on? This is like before or after?
Eventually I wrote the context switching code kind of after high school, but yeah, I mean, I was in high school and I was trying to figure out how all these things sort of fit together and reading operating systems textbooks and kind of hanging around the local university. And the sysadmins there were kind of my buddies. And so they gave me accounts on a bunch of the Unix machines and so forth, and the Vaxxon and the PDP-10 and all of that sort of stuff. And so I got to kind of play around with all of that gear. But I, you know, as a high school student, I didn't really get it at the level that I get it now, for sure. And then when I went off to industry and I was like, I want to work on this, there was just no space to do that, you know?
Yeah.
And so I ended up, like, when I worked at Google, for example, most of my career there was working at the user space layer. I never worked on web stuff. Again, I just don't think I'm talented in the right kinds of ways to be successful at that sort of thing. But I spent a lot of time working on code that kind of would, you know, take an RPC and extract some arguments and do something with them and call another RPC or something along those lines. That's kind of most of what programmers at Google do.
But that qualifies as system software, doesn't it? Does it not? Is that not system software?
I don't think so. I don't think so.
All right. All right, so your definition is more restrictive, maybe.
Well, I mean, my definition of system software is software that we write for the use of other software systems, right? Which is kind of sounds circular and roundabout, but
yeah, that's my definition. Okay, yeah, it makes sense.
Yeah, and so in that sense, I mean, like the stuff I was working on was what I think back in the day would have called application level software. You know, as distinct from the system software, which is like for the running of the computer and the consumption of other programs. Like you write a text editor or something like that. To me, that's system software.
Yeah.
You know, because you're writing that for a programmer or, you know, a user in that sort of category. Versus if you're writing like something which is designed to be used by an end user or, you know, transaction processing system or something like that, that doesn't feel like system software in the same way.
Yeah. Fair enough. All right, so I want to get to you in a second here. Before I do, though, Patrick, if you're here, I wonder if you might give your story because I think it's actually I want to get to kind of answering this question in the DMs about like what can people, how do you kind of break into system software? Patrick, I don't know if you want to talk about your story a bit because I think it's pretty interesting.
Sure, although I'm not certain that it answers that question so much. I mean. But I was working doing system administration stuff at a cereal company here in the Midwest, and started doing. I unlike your experience of having like a really crisp operating systems course that kind of crystallized all that interest for you, the OS course at Iowa State was fine, but it was not I hear about, like the folks from Brown talking about the OS course there, and it sounds very magical, and the course that I took was not that. So
right. Less magical.
Well, yeah, I mean,
which I think is honestly, I think the more typical one.
Yeah, absolutely. I mean, I think that is the norm, and I've sat in a surprising number of OS classes in like schools that are renowned for computer science, and seen some very odd descriptions to sophomores and freshmen.
Yeah, I mean, it was kind of much more abstract, and like the big project was just like write a shell, and it just wasn't, you talk about like scheduling in the abstract and paging in the abstract, but it wasn't like, go implement part of an operating system.
Yeah.
Which I think makes a lot of that more crisp. So, but I mean that there were like extracurriculars and things through. I worked as a web developer and like had a group of friends that did like a bunch of goofy stuff with computers in a lab, that sort of maintain that interest. I thought that Adam's point about rigor and curiosity I found to be very on point for getting into system stuff. So when I was doing kind of sysadmin ops work, it was often like we would have systems that were misbehaving, and it was like, how do you gain visibility into this? And these were, a lot of it was like HPUX machines, so it wasn't like open source where you can go read the source code to the thing. It was like, here are the tools that they give you, but like how can you understand what's going on in the system, but from the standpoint of not a system software developer, but like an operations person. Like what tools do they give you for that sort of thing?
So, and Patrick, that's really interesting, because when you're debugging a problem like that, especially in the proprietary era, but now as well, I mean, when you're debugging something, you're debugging a system that's not working properly. You really are right at that confluence of rigor and curiosity, where and you are and I mean, okay, like, yeah, I'm talking my book, but I really do feel that one of the things that typifies system software is a real emphasis on debugging and the methodology of debugging. The idea that like, hey, this stuff is knowable. You can actually, like, something that looked like it was totally magical that you had no understanding of, you were able to grind away for some period and like, oh, we figured out what it was. I mean, Patrick, you must have had that happen a couple of times. I assume is that where kind of the light was beginning to go on of like, wow, this is really interesting down here?
So I mean, like I was interested in system stuff and trying to understand it certainly wasn't it wasn't something that like I was being paid to do, right? It was just like the system would be misbehaving, especially for the things like the HPUX machines. You're kind of at the mercy of HP. Again, you're not reading the source code. You're not going to get to ground on a problem like you would if you were the developer of the software or had access to the source. But it was, like when we would have like a performance problem or a correctness problem, it was like try and get as many answers as you could out of, if you found an experienced engineer that you were working with, like they would give you answers and that would offer kind of a better window into what it was you were seeing, or why it was happening, how you might avoid that in the future, that sort of thing.
And then so you should talk about how we crossed paths initially, which was, how many years is that 10 years ago now? I feel like it might be. It's getting there.
Getting there. So I had been working on, there was a need in the company, a non-wholly owned subsidiary at General Mills needed access to part of the Active Directory for like an address book thing. And I had found Mark's work of LDAP.js, which was like the only means by which you could kind of conjure up a LDAP server of like arbitrary data, not like OpenLDAP or anything. I wanted to do filtering on the fly of the LDAP from our Active Directories so that this non-wholly owned subsidiary could like have an address book but not get everything in AD. So I was writing patches to LDAP.js so that I could do these goofy things to filter an address book. And apparently y'all at Joint appreciated that work.
Definitely. So, I mean, there's a bunch there. Adam, did you know this story? I don't know if you knew this.
No, not at all. This is all news to me.
Yeah. So first of all, like do not adjust your Twitter Spaces. You are hearing correctly. This is an LDAP server written in JavaScript. If you were just wondering if that was like you were hallucinating that or not, it was the fashion of the day. So this is an LDAP server written in Node. And Patrick, I think that there's a bunch that's actually really interesting about that. So first of all, like you had this problem that is a pretty filthy problem, and I think you came up with like a pretty. I think it would have been a less curious person would have been like, I don't know, I'm going to get some proprietary software. I don't know. Like, I actually don't know how you would solve that problem because as you said, the existing LDAP servers weren't going to cut it. How would you have solved it without LDAP.js? I mean, I guess I
think you would have had to like replicate out of AD into some custom. Like you would have had to use client software to like periodically replicate. But like then it's how often do you replicate? Is it out of date? Like I didn't have the privileges with the Windows folks to like get some stream of data, so you would have needed to pull it. And being like a big corporate environment, Active Directory was just absolutely massive, right? Like 30,000 users, 60,000 groups. It was like you don't want to be walking over this thing once every 5 minutes or whatever. So like acting as a server that proxied requests was like clearly the way to go. And JavaScript wouldn't have been my first choice, but it was for something that could do that was like the only choice in that moment.
Patrick, did your colleagues at the time, did they agree with this approach? Was it obvious to everyone, or?
I just went and did this.
Yeah, right. Just solve the problem. Right. Exactly.
Got it. That
and
I believe
people were thrilled that the problem was solved. It was like I don't want to hear how it was solved. Like
right.
You know what? I feel like this is my experience of being your colleague now too.
Right. Exactly.
There was a problem and now it's solved, or maybe I never even knew that there was a problem.
Right. You could just imagine being like, no, of course we don't have an LDAP server written in JavaScript. Patrick, tell them what you did. You didn't. It's like, no, that's what I did. Like, oh my God, wait, what? But so the part of the reason I think that that story is so interesting, Patrick, is because you were using the software as open source and you started contributing patches to it. And meanwhile, on the other end of this, we're like, who the hell is this person? Like all of a sudden, we're getting like not just these kind of like not like easy stuff or like kind of the drive-by fixes, but getting some deep stuff that was clearly showing some real use of this. And I just remember Mark Cabbage coming to me and like, I don't got no idea who this person is, but we've absolutely got to hire them because they are like, I'm going through the code and the code is like really clean. And Patrick, you and I mean, funny because Josh here as well, because Josh, I think you were about the same time, also came in through open source. And you, and Adam, I don't know if you knew this, but Josh had done the original SVN work for KVM, right, Josh? I think I'm remembering that correctly.
On Illumos.
On Lewis,
because the only machine I had was an AMD machine, and I was extremely sad that Smartos didn't work on it.
But it's same kind of thing. I mean, it's a little bit different in that it was more coming out of a community as opposed to solving a problem at work. I think, Josh, right? I think that was more just like this is the machine I got.
Yeah, I mean, it was at the time. It was the large scale distraction that I needed to prevent myself from doing my final year project at uni.
There you go. Right.
But
you got this.
I did get it done in the end.
It being uni or it being the AMD support? I guess
the degrees. Yeah, no.
The degrees.
I mean, I'm here now, so that's. I had been in the open source community since that was started, which was like 2005, I think. And then we started Illumos like when Oracle did the thing that they did.
They did the thing the Oracle thing that they do. But I think
the unpleasantness. Yeah.
The unpleasantness. And Josh, is our first conversation as vivid for you as it is for me?
Yeah, I remember you said we talked we were on Skype, and you were in an airport, and you were surprised at the fidelity of the phone call. I think you said it's like you're inside my brain.
Okay, that's what you remember from that story. Is like
that's what I remember from that.
Did I talk about John von Neumann? Like, was there any?
Well, I mean, I couldn't see him, obviously.
That's right. So what I remember from that conversation is me saying, I just need to ascertain that you're the same person that did this work that I'm looking at, because the work is, and I feel like, Patrick, it's in your case as well. I mean, I definitely.
You're asking him to cut himself in half and prove that he's not made of cake.
That's exactly what I asked him to do, and unfortunately, he did cut himself in half and grievously injured himself. But he was not made of cake, so we hired him. Not a win.
Perfect.
But then several months later, after I've been reassembled.
That's right. But I think that in both of these cases, because I do think that this is actionable, I feel, for people looking to this is where open source has changed, like, I feel, everything about the way we do software development. And the ability to find someone over the internet who you have not even in the same country, in your case, Josh, not the same part of the country, in your case, Patrick, someone I've got like no overlap with. I mean, Patrick, yours in particular, because like we had like zero overlap, but we shared a zeitgeist, an ethos, an interest, and obviously, like, we hired you at Joyent. I mean, obviously you're terrific at Joyent, and then you kept going deeper and deeper and deeper into kernel work. And I remember, and Patrick, I'm not sure if I'm making this up or not, but I do feel there was a time when you were like, I didn't envision myself, like, I'm actually doing kernel development. I for whatever reason, I had this kind of mystique about it. I didn't envision myself doing it, but hey, here I am. As it turns out, it's just a program.
Yeah, I mean, I came in doing mostly Upstack stuff, at least for the first little while before you suggested working on LX, which is where I got into the kernel stuff. And yeah, I don't know if it's your line or Josh's line about kernel programming, where
it's just a big C program.
Just a basic program, yeah, and it's true.
It is a big, complicated asynchronous C program. That's exactly right. And then, of course, like, as Adam, to your earlier point, like, the kernel is not even in charge of anything anymore because it's sitting on virtual hardware. I mean, it obviously is, but it's sitting in its own little sculpted reality. And turns out there are tons of layers, previously hitherto unseen layers beneath it, that are also really interesting. So I feel that, I mean, Patrick, would you counsel someone, I mean, based on your experience, because it feels to me like something we can take away from that is it is actually really worth not just understanding what a body of software is, but really getting deeply in to a community that you find interesting for whatever reason, and get to the point where you're actually, like, helping them debug the software. I think everyone loves someone who's helping them debug software. Is that a fair inference?
Yeah, it's so hard to make generalizations about a path to success there, I think.
Right.
I agree.
And like, I know that I was extremely fortunate to have all of the spare capacity in my life and all of the, like, advantages that allowed me to spend a bunch of time doing frivolous, like, non-university related stuff, for instance, like on the side, because it was interesting to me and because it helped me with something that I was trying to do. But like, if I'd had to work 2 jobs or something, like, already, I definitely wouldn't have had time to do all that stuff. So it's clearly, like, not a one-size-fits-all approach, right. I think.
I think it's also really hard to generalize because a lot of this is very dependent on community. And I think, much of this discussion, just given people's backgrounds, is sort of gravitating towards the Illumos community and things that came out of Joyent and so forth. But elsewhere in the systems world, things are not quite so collegial very often. Like seriously, and I think that it can be really difficult to break into that community unless you're kind of already somebody in the community.
So I think that's not just collegial, but we're a very small pond, and like the LDAP.js pond was even smaller than the Illumos pond, for instance.
The LDAP.js pond had 2 fish in it.
Like you as a person of reasonable competence and drive and with a problem to solve can show up and become an outsized influence in that pond generally merely by being easy to work with and doing lots of good things. which is probably not true in Linux, for instance. Just because there are so many voices in that room, it would be hard to be noticed and prominent without also having done other brand building work on your own, I think.
Yeah, well, and which I think is actually an important point. I love small communities. I think people get too hung up on the size of communities. Small communities are often amazing, and Dan, totally agree with you. There's plenty of bad behavior in in-groups and so on, but small communities can be something to gravitate towards. And again, one should be going to the software that's of interest. But
and important to just hit on the head again. Motivated by something you're building or doing, and something that's, in Patrick's case, motivated by something his job needed, although they didn't know how he was doing it, or in Josh's case, in his own self-interest or a personal interest. But I think showing up to a community and saying, "What can I do?" is a tough way to get in, and I think that in particular that's going to be tough, in Linux. But if you've got some interesting problem, I think small or large community, if you're doing something that is interesting to you, you're going to produce some artifacts that are interesting to other members of those communities.
Totally. Antranik, I know you had your hand up a long time ago, so let's get to you and then Simeon. Antranik, sorry about that if you're still there.
I'm here, but I'm here. Well, last time in the space I fall asleep, by the way, but now.
Well, listen, that's why I wanted to, I was trying to find the rouse button. But I know it is. I mean, people should know that it is like, what time is it? Is it 3 in the morning there? 4 in the morning? I mean, it's
4:51.
4:51, exactly. So there's good reason for it.
I think I forgot. Oh yeah, I just remembered. So we have a team in the company that basically their only job is to write dtrace code. Well, it's a one man team, to be honest. And he was always saying in his Slack bio system programming wannabe. And I just want to tell him that is system programming. You are doing system programming. So my question now, is that system programming, and are we in a state that if someone is not writing code for the user, we should always ask ourselves, is this system programming?
I mean, obviously for me, I think that is absolutely system programming, even though he's writing in a non-Turing complete language. But I think it is definitely system programming, because I think it is, again, Adam, circling around on your rubric of rigor and curiosity, those are being exhibited in spades in someone who is instrumenting the system, be it dtrace or BPF or however you're doing it, writing that kind of meta code or meta thought to go debug the system, I think is absolutely systems programming, in my opinion.
And one, so my last question is, I had the honor to be I think it's called a TA, a teacher assistant in a university for an OS class. And what I realized is that students don't have interest in low level stuff. Why is that? Is it because it's less demo-y? And on the point that Dan said about is not being profitable, I just realized that we are maybe right now in a state where it's exactly the opposite. For example, let's take Netflix with FreeBSD. The more they invested in FreeBSD as in system programming, the more they got out of it, bandwidth-wise and performance stuff like that. Are we reversing the action of system programming to revenue in this age? Also with Rust coming in, making it more safe and easier and faster to write these software?
I don't know. I mean, look, I think one of the things with a Netflix is that there's kind of, half a dozen companies or something in the world that operate at that scale. And for those companies, it makes a lot of sense to hire a lot of systems programmers. I mean, Microsoft might be the canonical example here. It's they actually market and sell an operating system that people, continue to pay good money for. So, surely they need to hire a lot of systems people. And, but most places are just not like that. And, for a lot of these places, like Netflix, it makes sense because they have this, they can leverage economies of scale, but a much smaller organization cannot. And for them, it makes a lot more sense to treat, say, an operating system like a commodity.
Well, but I do think, though, Dan, that system software that is responsible for running other software is very important in many different spots, and there's more demand, I think, still than there is supply of those folks. And so I think, in terms of your question about why do students seem incurious about it? My answer to that is students need to be, just putting myself when I was 18 years old. I needed to be broken a little bit. I needed to appreciate that all of these abstractions that had been created for me to give me this kind of delusion of how simple the software is, because the abstractions are simple, just like Dan, your read system call. It's like it's a straightforward abstraction. It's a simple abstraction. And on and on and on up the stack, we give people these insulating simple abstractions. And then we say, like, well, why are you incurious about all the software below? And I think people are like, wait, what software below? What's going on? It's, we need to actually, like, you've spent all of your life as a programmer, as someone experimenting with software, being insulated by these abstractions, and now we actually need to break them down, and we actually need to show you that these are very complicated systems, and we can't insulate you from them any longer. So I think that and that requires a great teacher. I do think that I guess I'm an old schooler in that regard, that I think great teachers can make a really profound difference for the right person.
Yeah, we ended up having only one person who got interested, and he ended up writing a package manager for a language called Oberon, which I thought.
Oh, nice. There you go. Yeah.
But only one person out of like 200. But it was good enough, to have something that their small community of 15 people was interested for 20 years. But it sounds like a good book, breaking the stack.
That's right.
Under there.
That's right. That's exactly right. And I do feel like that there are more now. I think that the positive side is there are so many more resources available now than there ever have been before. And I love Ben Eater's series. You've got Tom, you talked about this deck book last time on the kind of building up the small system and being able to fit the whole thing in your head. I think there's more and more of that available than ever before. So I think that there's a lot of opportunity for people to learn, but then the question is, like, how do you to kind of mature that? Simeon, you've had your hand up for a long time. Whoop, Simeon, you still there?
Sorry, hear me?
Yep, we can hear you.
Sorry. Yeah, I think it's a very interesting topic. This, like, how do you get in? One of the thoughts I had. So Bryan, I love the idea of helping people debug stuff. I recently heard somebody describe reverse engineering as the debugging nobody asked you to do. That seems like a way to break down the doors. Something that I'd be interested in getting folks' input on is how do you do the how do you get into communities beyond just looking for an open source project in a GitHub? Go find GitHub issues and solve them for people. If you want to get into hardware and that sort of stuff, like, I know that Edwin, who's not on this call today, but he said he met you folks first time at, like, I think an open hardware meetup where you're taking a motherboard apart and, like, trying to, like, reflash a BIOS onto a motherboard or something like that. What are the venues, the tools, the ways that you can get into that kind of thing?
Yeah, that's actually a great question. And Rick, I was wondering if you might want to answer that, because actually Rick was there. Rick, Josh, and I were all there when Edwin was there at the OSFC in 2019. Tom was there too. But Rick, I wonder if you might want to take, because I think the reverse engineering point is actually a really good point. Another great way, and I think it's reverse engineering, I think, has got more, from my perspective, more currency and relevance than ever, because security is so important. But maybe I don't know, Rick, is that?
I think that's fair to say. I came to systems programming via a very roundabout way, and literally by accident. So, part of my career path is I actually started much more at the hardware level. Growing up, I had some people in my life who were very much into electronics and electrical work. And so, like, I understood that part really well, and I understood how to use a computer really well, but I really didn't understand anything of the intermediate parts. But I was always curious about how they worked. And just, my career path, I grew up in a very rural area in Ohio. I went to a state school in Ohio. I did not have a particularly good chance of entering into high tech at the big companies, yet here I am. Partly that was literally due to a clerical error. So sometimes when people are worried about, what's the path in, just part of it is luck, and part of it is keeping your eyes open for different opportunities, and looking, past kind of what the surface value of an opportunity is. But specifically getting into like the curiosity part and reverse engineering, like I was dropped into a situation where I was literally told, "Hi, you now work at Apple. We are designing a new machine based on a new processor that nobody's talked about, and it has bugs, and we need you to go characterize the performance of it. Have fun." And so I was just given a ton of material and told to go figure this stuff out, and I didn't know what I was doing. But I also knew that because it was a system that was not fully defined, I had a lot of room to experiment, and I shouldn't be afraid to break things. So a lot of reverse engineering, a lot of curiosity boils down to feeling like you have the permission to go try things and experiment, and realizing that you're unlikely to permanently damage something. Like, there are things that can do that, but for the most part, you can just do really deep things to your system and see what happens. And then when you don't understand what happened, then you go find the community that can answer that question. And that's when you start to find these communities where you're like, oh, there's the OS dev channel on LiberaChat that talk about all the like system mode bring up stuff. But they don't necessarily get down into the deeper details of the electrical side of how the hardware works. And, that's a different community. And on reverse engineering, it's kind of coming at it from this perspective of, I understand how the lowest levels of the system work, but I don't necessarily know how the upper layers work. Or I know how the upper layers work, but I don't necessarily know how the lower layers work. How can I do experiments to kind of figure out what's going on? How can I use the information I have to put together a picture of how it probably works, and then go test that theory? And, that's my career in a nutshell, is basically just poking at things, seeing what happens. When I can't get a clear answer, when I'm stumped, going and finding somebody who at least can point me in the right direction, or be a really good rubber duck to kind of let me figure out what direction to go explore.
Yeah, and actually, Rick, you're getting to another on brand for us, but another Oxide value as well in terms of resilience and kind of continuing to grind and like, okay, I've tried, I don't understand this, what's going on? And instead of hitting, a dead end where other people might kind of walk away, being like, no, I need to go like find the resource, find whether it's online or and ask the questions and try different things. I really like your point about that too, because I feel that, often when you're stuck on a problem, it can help you just to get out of a local minimum by just trying some different things. And that can be hard to do, I feel like we can get ossified in our thinking. It can be hard to remind ourselves to play around a bit. And because Rick, you also made another really interesting point about doing things that were not assured of success, of like, I'm just going to explore this. I don't know if this is a path that's fruitful or not. I feel that that's also a very kind of important theme for doing systems work.
That's the agony and the ecstasy of systems programming. And I think that Rick hit on something really important that we don't emphasize enough, which is that these systems have become so incredibly complex that you cannot reason about them from first principles anymore. You have to take an experimental scientific approach to understanding the behavior of non-trivial systems.
Yeah.
Period. End of story.
Yep. Yeah, that's very true. And that's a very good point, that these are like, these systems are even the simple ones are fiendishly complicated. And you've got to have an idea, because Rick, you described having an idea of like, I think the system works this way. What can I go kind of construct to answer that question definitively? I think is a very, and so Rick, I have to say, I'm dying of curiosity about the clerical error. Is that because is Apple your first big break, or was there one before Apple?
Yeah, so my university, I went to University of Cincinnati, and they're the origin of co-ops. Like they literally created that entire concept. So it's a mandatory part of the curriculum is to take alternating 6-month periods and go work in industry and then come back to school and go back to industry and come back to school. And the school helps find jobs for you. And usually they found things in the Cincinnati area, but sometimes people got more interesting things. And it just happened that a friend of mine, the placement office accidentally sent his resume to Apple, and he got selected. And they were completely aghast and like trying to tell him he can't possibly go do this. And then Apple's like, no, seriously, we really want you to come out. And from there, it led into a word of mouth. Like, these are the people who are really good from this school, and it set up a pipeline of people for at least a few years. But yeah, I literally am sort of a one step removed from a literal clerical,
a literal mistake
from Ohio to the.
And Rick, do you think that increasingly in a remote world, regardless of whatever trolling VCs say, Founders Fund can go jump in a lake. Increasingly in a remote world, certainly in an open source world, do some of those geographical boundaries break down a little bit? Does the Rick Alpert graduating from the University of Cincinnati today, is that person less dependent upon a clerical error to get into this stuff?
I would like to hope so.
That's it. Well, I think it's pretty good.
Well, yeah, I mean, it could really go either go away. Where in terms of acting, you would go to LA to be discovered, and I think there was certainly a time when in software engineering, you would go to San Francisco and the Bay Area to be discovered, which created a hurdle in one sense, but sort of a leap of faith that folks could take. But now with an all remote world, I think it's more egalitarian, certainly, but I think it may actually be harder to distinguish yourself as well.
Interesting. Yeah, certainly there's a bigger pool for sure. I mean, we benefit. I mean, but boy, there are so many folks that we have the privilege of working with at Oxide that I just feel like we would not be working with in a non-remote world. So it's been really, really transformative and important. Nathaniel, I think you had your hand up next.
No, actually, I think it was Matt.
Oh, it's Matt. Sorry, Matt. Go ahead.
Hey, guys. So getting back to the topic of incurious students and why people aren't more curious about the low-level stuff, I wonder if part of the problem is that on our modern computers, especially, I would say, the sandboxed mobile and tablet type devices, the insulation that you were talking about earlier is too perfect. Like,
it's awfully good. Yeah, I do feel this way about I love the Chromebook, and I think the Chromebook is an incredibly important and undersung product. But the Chromebook is so secure that kids can't. I mean, it's very hard for kids to, the old war games of hacking in and changing their grade to an A or whatever. Like, you're definitely not doing that via a Chromebook. And
well, even as far back, I would say, as Windows XP. You were running atop a robust enough foundation that you couldn't. Well, so maybe this is just nostalgia talking, but I remember on my family's first computer, the Apple IIgs, I started getting at least little glimpses of how things worked on a low level as when I was a little kid. Like, Bryan, I'm sure you remember on the 2GS, if you pressed, I think it was Control Open Apple Escape, it would like trigger an interrupt that would go into this control panel UI. And
I would say that 100% of my time on an Apple IIgs was at my neighbor's house getting my ass kicked on Epic's games.
Right. Okay. So you didn't get near as deep into it, probably. But yeah. So, and of course, the 2GS wasn't a multitasking machine, but still, it had this thing, this command that could trigger an interrupt and interrupt whatever you were doing and take you somewhere else. And at some point I noticed that if I was running some 2GS game that was like playing music in the background, then I could switch into this control panel UI but the music would keep playing. How does that work?
Interesting.
And it didn't take me long to figure out that if I dropped into the monitor, which was this Apple II, basically a REPL for assembler for like where you could like enter lines of assembly language and run them, as I recall. And it didn't take me long to figure out that like if I disabled interrupts, the sound would start looping on whatever half second it had been playing or something like that.
So to give you some, okay, so I hear what you're saying, certainly.
Yeah.
I do think that there, and totally, like, I think the phones in particular are very hard to, I mean, they're far too sophisticated. You're not going to hack in, it's too hard to hack in your phone. I do feel that the two things I would say are, one, I see, at least with my own kids, Minecraft getting, I do think, we're talking about, is Minecraft systems programming? I think we're going to have to say it probably is getting there, based on some of the things that kids today are building with Minecraft, where you are getting into kind of the blocks of the way things work. The other thing I would say is, the thing I do love about this day and age is these eval boards where you can have these super cheap computers that have everything on it. Now, they don't have, it's not a 2GS, so you're not playing, you're not, and maybe that's what makes it hard for kids to get captivated by it. But there's a sense in which it's actually, things are very accessible in a way that they haven't been.
Matt, it's funny you took this route, because as you were talking about Chromebooks and these locked down phones, I was thinking about, the point of curiosity that a lot of kids go through is cheating at video games. And I certainly did. Kind of figuring out how to, hack shareware games. I would
have had to be able to play the games in order to cheat at them, but yeah.
Right.
Yeah, fair enough. But I was thinking on the phone, one of the first kind of pieces of hex editing my now 16-year-old, but then like 9-year-old was doing, was to cheat at a video game on the phone, where they could extract kind of data files from the phone to the computer and then stuff them back in after editing, aspects of the save file. So I think that even as things feel locked down and things feel kind of curated in this walled garden, there are lots of little edges for curious fingers to get underneath.
That's an awesome anecdote. And I also feel that because, you've got, especially your older has got that real disposition, Adam. So it's good to know that the kids are definitely all right. I also think that, like, I don't know if he does robotics team, but the whole robotics team did not exist when I was a kid. And that's, I think, another way that kids are really understanding how things work in a way that's exciting to them. Certainly my daughter is just loving that stuff. Hey, quick note, we've got a lot of folks with their hands up. I want to get to them, and then we've got actually a lot of folks that are waiting to speak because Twitter Spaces has a very low cap on speakers. If you've requested to speak and can't speak yet, it's because we can only have whatever it is, 12 speakers. So
so if you've said your piece too, making space for someone else would be appreciated.
Yeah, it would be great. On that note, Nathaniel, and then I think Kaleem, and then I know Patrick, you had your hand up, and then Dan.
So it's funny that you sort of brought up the computing for kids thing, because I've been thinking about this a bit lately. Because one of the things that I did in undergrad when I was bored was I ported Inferno to L4, just because. So if you don't know what Inferno is, it's a sort of reimagined Plan 9 of sorts that runs inside its own sort of virtual machine, and it has like the language called Limbo in it. There's a compiler for it. Limbo is kind of like Golang, except came with generics at first, which is kind of interesting. But no, I've been thinking about this because if you want to sort of get kids interested in systems programming, Plan 9 on the Raspberry Pi 4 is actually a small enough system that, like, the C compiler is like 5,000 lines. It's tiny, and like it's a small system. There aren't that many syscalls to it. Everything is through 9p, and like it might be worth looking into if you want to sort of try to get somebody who's undergrad, high school level to get interested in like C programming and like how does an OS work. I think Plan 9 is also hard real time, so you kind of get that aspect as well. But I'll let Dan grumble about it. There was also a mention, a note from Dan too about OS as a commodity. So I used to work for a boutique hosting company who hosts like InfoQ and like used to host Atlassian's corporate infrastructure, and we were contracted out to build out the hosting platform for Jira Studio back in the day. And I wrote the cluster scheduler for that back in like 2010, back before containerization was actually kind of a household name. It was one of those things that we just did because we needed the tenancy. And running a whole bunch of virtual machines across however many tenants we had. I think we had like 15,000 tenants or something. It was low 10 to the fifth. Was just not tenable. Like you just couldn't pack VMs tight enough for that. So we wrote this piece of software in C++ 03, like ISO standard C++, that just farmed out processes to machines and did the thing. And they'll come to find out that Google had Borg at the time. And,
right. Yeah. Right.
And so what's really funny about the thing that we had internally was that it was actually called Babysitter. And come to find out that Google actually had their own thing called Babysitter that was sort of like the, as you would probably phrase it, Bryan, the Borg, right? The sort of like the primordial version of Borg. And it was basically just a process supervisor. So if you're familiar with daemon tools or run it, it was sort of in that same vein, except we just made it distributed. So we had a job queue sort of sitting way out in front on a machine somewhere. It was just an append-only database, append-only log. But yeah, so actually the way that I got into systems programming, sort of like to cap this all off, was to I think Adam's point. I was looking at like cheating at games, and this is actually sort of my entrance into the demo scene. I used to write cracks for like Commodore 64 games. You'd get the disc from your friend who worked at the video game store, and you would spend like the weekend cracking the bootloader because there would be copy protection or something on it. So you go into the C64 assembly monitor and you figure out how to sort of NOP sled your way out of it, and that was that. And then if you had enough space left over, you could just write like a short scroller or whatever in there to draw pretty colors on the display while the game loaded up. What's funny is when I was in high school, we had an electronics program. So like you did solid state and digital and the whole 9 yards. And there was a sort of microcomputing component to it. And we had this like Z80 trainer for like, you would hand assemble Z80 code and you would enter it into like this panel with switches, and then like you would press the step switch. And
wow.
One of my yeah. And this was
That feels very dreamlike. Did that actually happen, or is that? I mean, it just feels like
it's a real thing. So
wow.
what I wound up doing was actually for my senior project in high school was I put together a version of that, also for the Z80, but with a few different sort of takes on it. So there's some documentation on the Game Boy and like the sound hardware, and the Game Boy was also a Z80 machine. So I was like, maybe I can do something with like some oscillators and like build my own sound hardware for my own version of this, and like just sort of make a chiptune synth out of it.
So yeah, Game Boy hacking is like a huge thing. We got a colleague who's super into Game Boy hacking, and it's really interesting. I mean,
there's a lot to it. It is a surprisingly deep little piece of hardware, and like this is a thing from 1988. This is a little like AA powered device with a Z80 in it, and like some sound hardware to sort of make beeps and bloops, and something to refresh the display. But like it's actually surprisingly deep. So that was my senior project in high school. Was I put together sort of this like chiptune synthesizer thing, and then
it's so in terms of like kind of getting back to the kind of the question at hand. So if someone's looking to kind of break into this stuff professionally, who's been doing maybe higher level software, more application focused software for a period, like what's the like? So I do want to kind of get us to like what's the advice for folks who want to get lower, and kind of while you're thinking about that, I want to get Kaleem, your hand's been up for a long time. I want to get you in here as well.
Yeah, thank you, Bryan. Can you hear me first of all?
Yep, we can hear you.
Yeah, so I want to take this narrative of system programming and why new folks are not doing it. I think I'm going to share my experience. I think that's very relatable to this. I think the way If you look at the old docs, right, they are just like books. So whenever I was learning like Java Spring, like a couple of years back, I would read the docs. I would be like, say, okay, I want to go deep into this. And then the documentations are horrible, to be honest. They are not interactive in a sense that they are not on the point. So there is no hook. The way I see that, I just had a Twitter space, by the way, with Dan on this topic. He writes docs for the Solid.js, so he had a very strong views there. So the thing is, as long as even if you want to build interest, this is in general true. You need to provide the active value. If your docs are just like books in like 700 page, I don't necessarily see anybody would be interested. I don't think this is a problem with system programming, but this is true in general. If you look at like Spring Docs, I see this because this is a very relatable experience I share. If you look at Spring Docs and you just see you want to learn, you would see that they're teaching you XML, which is almost obsolete, and you just want to get started in like 20 minutes. One more thing I see, if you look at the modern way that the things are taught, is educative.io.
So actually, can we, before we get to that, can we just talk about docs for a second? I think you've hit on a really important point here, Kaleem. Because I do feel that a hallmark of a great system, of great system software, is great documentation. And I feel that our colleague Cliff Biffle has done. If you've gone into the Hubris documentation, has really spent a lot of time. It takes a lot of time to sculpt that documentation, and I do feel that it's more the exception than the rule. And so, Kaleem, are there particular systems that I don't know? Have you read the Hubris docs, by the way?
Yeah, unbelievable. I mean, like everything that Cliff has done, it's just an incredible job.
Just extraordinary, and very. It makes it very accessible too, because it means that someone can kind of roll up to it. Kaleem, to kind of your point, I want to understand why. What is the why behind this thing? And I think that a good system software documentation has that crisp why. And I think it is a bit lacking. Kaleem, are there systems that you think today have particularly compelling documentation, or is it something that in your esteem has just kind of been going downhill?
Yeah, I think let me put it this way from the learning perspective, right? I'm just trying to be very generic in a sense, and that can apply to system software. If you look at, educative.io in a sense, because I was just enrolled in there, one of the courses, and the way they make it so easy is that their websites provide the experience of you can create notes, you can have animated gifs that you can go back and forth. So it's not just docs in terms of docs, it's a whole learning experience. Because if you look at it, how we learn, or how today we learn, the textbook way is kind of getting overpassed by the web, right? Anything you put, what I'm trying to focus is more on overall learning experience. If we have, let's say, systems, some kind of docs that is that has does visual elements that are like, one example I would go is that if you go to educative.io, one thing I like about them is that if they're explaining you how URL shortener works, right? This is a recent example. Instead of telling you everything, you have a visual which you can, play back and forth and then read their description. So it is very relatable experience. I don't necessarily think there's a problem with the system programming docs, but this is more about a modern way, how we have to see things to, attract our newcomers, right? The way newcomers come is that they go to Mernstack. They go for, I can't remember every framework. Like, this is how things are evolving. I think this is a perspective because I come from that era, like recent era. So I don't come from like 10 years back. So this is a new perspective. I think if we start thinking from a learning perspective, experience perspective, rather than saying that, hey, this doc is perfect because this matches some standard. Of course it does, but you have to see that I see that every documentation should have, if it's on web, should have like 3 versions, because every reader is not gonna understand your crisp, like concise language. It might be perfect, but if you look at somebody's trying to get in, they are going to have a hard time. They might need to read it like 10 times or 7 times, which is not necessarily desirable. So if you have a beginner friendly, like informal language that explains docs, I think that's a very good learning experience, and that's going to grow your interest, if in simple words, rather than saying that this is a perfect docs because it is compliant to this standard.
Yeah, interesting. And yeah, no, that I've not gone on educate.io, but it definitely looks interesting. And it certainly feels like there's a lot of new ways to learn systems out there. In terms of who is the Anno 0770, I think are you next?
I think Ian was first.
Okay, there you go for it. You are also you're so courteous.
So you're currently hiring for a couple of positions that could be considered systems programming positions. As a hiring manager, if you're hiring someone who is changing roles from a role maybe higher up the stack to this role, what sorts of things are you looking for in terms of someone who is curious about going into that role? Like, how would they pick up Rust, which is likely the language that they're going to be working in, and potentially, like you mentioned, a Arduino pet washing coffee maker. If you got examples of projects that people could pick up on the side to be able to like brush up their skills in that area.
Yeah, and I don't know how representative we are or not. I feel that I think I've said this before, but one of the things that is hardest about Oxide for me personally is just the sheer number of folks that we have that want to work for the company, which is great. And I feel that it's actually given me great confidence that there are lots of systems folks out there, because we see we have people do these materials where they're talking about things that are meaningful for them or that they're proud of as a portfolio of work. And there's a lot of really, really, really great stuff out there. I think that we've got a lot of folks that are that have changed directions or are and I do think that my colleagues speak to this as well, but I do feel that we are looking for pretty intense curiosity, and then you're looking for a kind of doggedness, I do feel. And I think that I feel Rick hit on this earlier with the resilience. I feel that systems will resist being understood, and you need a certain monomaniacal kind of focus to actually will these systems into being understood sometimes. So I think we're kind of looking for that as well. But again, I don't know that we're represented.
But you already, from the perspective of a hiring manager, to a degree, you already answered this with, Patrick and Josh's stories of folks who showed up and contributed in really meaningful ways, and
that has been true at Oxide as well.
That's right, and I think if folks were, for example, using something like Dropshot, our web framework, or Hubris, our embedded operating system, and we're using it and contributing positively, that would speak volumes and be an overweight factor compared with what they had done necessarily. But part of that is the authentic interest. We've also had folks show up and say, here are a bunch of Clippy knits that we drop in, and that's not unhelpful, but it doesn't show a depth of curiosity and use, and it's a different kind of contribution.
Yeah, no, I think you're totally right, Adam. And I think it's like we're not looking for you're interested in our software projects as kind of like as a sycophant. We're really looking for that deep natural interest, because it represents more of an alignment on how software should be built, and because we know that like the way we're doing things are not a fit for everybody, and that's okay. And so but yeah, when we do find that those kind of deep contributions, just like Patrick's LDAP.js back in the day, or Josh back in the day, you do realize like, okay, yeah, this is a kindred spirit, and it is definitely important. Ian, does that answer your question?
Yeah, it does. I was just kind of ruminating internally about how you could extrapolate the Oxide specificness of that to a broader, like, okay, now someone is applying to a systems job for another organization. What might that hiring manager be looking for a job changer? And it sounds like the commonalities there might be, contributions to open source projects that are relevant, and that level of curiosity to be able to apply that knowledge in a non-trivial fashion, or like in a more direct fashion. Would that be apt?
I think that would be apt, and I would also say, and if anyone is hiring technologists, please have a writing intensive process that allows people to demonstrate their who they are, and not just a resume and a cover letter. I feel that, I mean, Adam, I don't know if you feel the same way, but I know that, as I've said before, like, the hiring process that we have is a consequence of having done it grievously wrong in previous lives. And I can't imagine another way to do it, because we've had so many people, I feel, where you look at the resume and you're like, yeah, I don't know. Yeah, interesting. And then you look at the materials and you're like, whoa, okay, wow, really interesting. And conversely, you've had people who are like, wow, this resume is amazing. And then you look at the materials and you're like, these materials are a lot less amazing. Adam, I don't know if you've had that.
Yeah, no disagreement. But I would also say that, having hired at some other companies, we also have a fairly privileged position of that many folks wanting to show up and throwing up what to some might feel like an obstacle of our fairly writing intensive application process, it not necessarily creating too much of a bottleneck. Whereas for a lot of organizations, it is going to create that bottleneck.
Totally agreed. I do feel that the two questions that everybody should ask every candidate in writing before, I feel, what are you proud of? Talk about something that you're proud of, and why do you want to work here? Yes. I feel like
yeah, totally agree. Giving people the space to opine on what excites them is really motivating, and then understanding their connection to your company and your mission and your team. Absolutely. Couldn't agree more.
Yeah, you bet. NO0770, I don't know how to pronounce that.
That's perfectly fine. I wanted to give the question a small twist, namely, why didn't I end up going to system programming, although I was on the way? And basically, I've been into computer science for a long time, did OpenCourseware stuff, structure of interpretation in computer programming, the Lisp version, when I was 14, 16, because I found it interesting. And then around the age of 17, 18, I heard of operating system family I had never heard before. And the Tron operating system family from Japan. And it's really impressive stuff. They had plans for embedded operating system, desktop operating system, server operating system, custom CPUs, which are better for the real-time properties, which all those had, and that kind of stuff. And anyhow,
I can guarantee Adam does not know that there is a Tron reference in the kernel. Adam,
no.
Cyclics are a tip of the hat to Tron. Tron
has
Tron,
how about
that? Tron and it's like iTron, micro iTron. Anyway, Tron does not come up pretty frequently. Wow, it is a this was would compete against PSOS. This is for engine controls. This is super hard real time stuff. Anyway, go ahead.
And I basically was fascinated and digged through all their 60, 80, I'm not quite sure, English publications, because they're Japanese. They don't have that many English publications. But because there were a lot of people working on their complete architecture with all the different branches I told about, there was quite a little to dig through. And for a project for my school, I boiled all this down into 60, 80 roughly something of that magnitude of LaTeX pages, which were made to be understandable by a lay person understanding all the terms, and I had to dig all the terms from all its different disciplines. Tron later in the history didn't turn out because US imperialism, but that's beside the point. And the Japanese people, including the professor which got it started, were that impressed by the questions I asked doing my research to them, and they didn't have a full scope what I was doing, but they were so impressed that they said, you know what, we invite a person every year to our conference, to an annual conference. We only do embedded stuff, and it's no longer called iTron as it was before for industrial. It's now I'm not quite sure what the name is. I forgot it. Anyway, I was there and was nice, shaking hands, was fun. 3 years later, I poured their embedded operating system to an open source reimplementation of the Super H CPU architecture, which originally comes from Japan, was made by the people which previously worked on the Tron CPU, and there was a pre-existing iTron port I could draw from, and the open source implementation had basically no documentation. So I went into the VHDL code and tried to find out what the device registers are, try to learn all that from scratch, document what I learned, document what kernel changes.
Yeah, interesting.
And sorry, what compiler changes were made, that kind of stuff. And then I sent them that and that. Yeah, that's interesting. We are welcome to have you again, but you will have to pay your own flight and your own stay this time. Okay, that was fine. I managed to do that, and then I was there, and I was in the junior track or something like that for the conference, and nobody there talked about embedded, or one person talked about a payment system for a mobile payment system for buses. Another person talked about smart home, other thing, and in the same year there was a new version of this kernel release, a new specification, because it's all specification based, and then there's one default implementation. Anyhow, I didn't know there was a new version, so I sort of almost ported the old version, and then I learned that. But what was even worse, there was no person there to talk with me about the embedded stuff I did, about the work I did. Just yeah, we have a new version, yeah, and we have the spec. The spec also as PDF is available, but if you want it in print, it's $60 or something like that. So,
there's an interesting point here, though. I think in terms of we're talking about how does one get engaged. You got an open source project that's being worked on, that's got a company behind it, and one of a good way that to me that highlights of getting engaged is going in where there is Spartan documentation and adding to docs. I mean, that is something that can be really represent a lot of hard work that generally is going to be pretty welcome and is going to, I think, turn some heads.
I sort of did that with my paper, and that ended up in the track. It's published somewhere, probably under Springer, I don't know. Anyway, that was the one thing, and nothing came of it. I talked with them. There was nobody to talk about the better thing, but that was not all. I also studied all the VHDL code for these open source CPU implementation, and tried to dig into that. And there was no documentation. How the fuck can I say that word here? How does the interrupt controller work? Well, I dug into the VHDL and found an odd off by 1 error in the interrupt controller in the nanoseconds time register, where in the first run through it will go from 0 to 99999, and in all further runs it will go from 1 to 10 to the 9. So there was a one-off inconsistency between this thing, and I approached the people which did the open source reimplementation of the process and released it as a tarball and said, yeah, I found this bug here. I replicated it on the hardware you gave me, you sent me. I replicated that bug. It exists. I'm not imagining this. It's a minor bug, but can I get it upstream merged, something like that? And 2 weeks later, they said, we had a look at the code. That part of the code base has to thrown out anyway. No, we do not merge your code. No, we will not include your thing in the new tarball release. And was also it.
Yeah.
And that was it. And then I just
to Dan's point that even a small community can be not welcoming. That's definitely annoying.
And then with that experience and back in Germany where I'm from, basically I talked with someone a few years older than me, which came to visit our school, what he's doing in computer science, and then just it sounded like the first 1.5 2 years will be full of stuff I already taught myself. So I then kind of knew or what I do as like open source minimal viable product where I actually can have an impact. My idea was by popularizing and like giving this open source re-implementation of an old CPU architecture, which is now out of patent, which has a historical connection to the specific operating system, by like using this overlappingness, that connectedness, I can like slightly push the operating system market in that particular Japanese area, maybe a bit in that direction. No feedback at all. Nothing came from it. Nice. I go into different discipline. I find out how differential equations work.
Yeah, there you go. Right, exactly. Well, and so I mean, it's definitely not foolproof, certainly, but that's definitely an interesting tale. So, Timon, I think you're next, and I think we're definitely going way over here. So, I would love to maybe this might be our last comment. Timon, do you want to?
Yeah, sure. Can you hear me?
Yep, we can hear you.
Awesome. Yeah, my point was like a long time ago. You were, I think, talking a little bit about like smaller companies, not really needing systems programmers, and I just want to give you a point of like because a lot of the examples here, I think, were like around like operating systems or like anything kind of in that realm of like very close to hardware kind of systems. But yeah, I come more from I guess you could call it media systems. Like it's a like very different abstraction level. So like we build on top of course operating systems, but
I thought, did you say on top of Chorus?
Sorry, on top of operating systems. So like we build on top of the people that like operating systems. It's like we build systems on top of systems for systems.
Okay, and so do you view it as system software? I think to kind of to end where we started. Do you view that as system software?
Sorry, I didn't catch that.
Do you view that as system software? Because I think this is one of the things we were talking about earlier. Yeah. So there you go.
Yeah. So like my definition of system software or like systems is like it's software that is made up of little blocks that talk to each other and build one coherent thing, but individually they are useless. And I think the differentiating factor, because that could also be an application, but the differentiating factor is then that all these little blocks enable a whole different thing, another application or even another system to function. And that I do or did actually. I switched industries, but past 9 years I was making media systems. So for example, today museums, they are very interactive and they can be extremely complicated. So you have like 30, 40 different exhibits that quite often talk to 3 or 4 different other exhibits because you can interact with them, and then something else happens over there. And you have like embedded systems that talk to, a Linux system that does something, and you have a lot of small little things. And, I actually come from like visual effects and like from an artistic standpoint, and I kind of grew more into programming and into this space. And at some point I realized I'm actually building systems to enable these applications. So like, because they get so complex, because there's so much complexity in the interactions involved there, you have to write software to actually be able to write the software for the client. Because if you would do that from scratch every time, it's way too complicated. So you need to abstract away a lot of these complexities into something like a system that abstracts away some of these things for these little implementations that are specific to a client. And that was for a very small company. I wouldn't say it's also there's not a lot of money in that either. And I think if you reframe a little bit what a system is and are open to different things, if you're not maybe you're interested in embedded systems. I do a lot of embedded systems as well, and like that can be part of that. But it's a very different type of systems. But the thinking involved, like thinking about how things have to interact with each other, how all these little blocks have to mesh into each other, how they talk to each other, and how all of these things together make up something that make things work. I think that's a very similar methodology to an operating system.
Totally. Well, and I think this brings us around to a good finishing point, because this is actually kind of where we started in terms of that, Adam, your curiosity and rigor, that I think seems to be a theme we've seen throughout. And I think people being curious and then being rigorous in their own thinking, but whether they're debugging a system or documenting a system or reverse engineering a system, being tenacious and resilient and following that curiosity to the depths of the system feels to be like a pretty common theme that we're hearing in terms of how people got into this.
Yeah. One last anecdote I wanted to share was, a guy I went to high school with, we were both into computers. Like he hosted a BBS like on his second phone line. So I'd dial up and every once in a while, like his mom would pick up, and I went into computer science and he went into German studies and humanities. 20 years later, I bump into him in Berkeley, and he, now as like a grown up with kids, decides to go back to school to earn a master's in computer science.
Oh, interesting.
So spend a bunch of time, learning a totally new discipline, new field. And so there was, and forgive me because I've been reading Bowling Alone, so I've got the nomenclature of human capital, which what he was building.
I love Bowling.
But then a lot of what we've been talking about with these communities, whether it's on GitHub, an open source project, or live in these conferences or whatever, is human capital and who you know. And so my buddy got a new job out of this master's program, which was awesome. Not something he was fired up about. But then another friend of mine, my buddy Lucas, Bryan, your buddy Lucas as well, who's been on the show before.
I just want to make sure it's the same person.
Working at a startup, knew the guy, said, "Hey, I think you can do this job. But I've met you, I've talked to you about stuff. So, and I've evaluated your talents." And goes to the startup. Startup gets acquired by Apple. It's a terrific success story for him. I'm very excited for him. Really pleased for him. But also that it's that confluence of learning and demonstrating what you know, but then also making those connections, whether through open source communities, in person, through your own networks of school and friends and community and whatever, that get you to those. And there's probably no silver bullet, but it is building both knowledge and connection.
Yeah, and you can't just rely on the kind of the cover letter or apply, especially if you're coming from a non-traditional background or one that's kind of a later discovery that this is as a calling. You've really probably have to emphasize that human capital even more.
Yeah.
That's good. Well, that brings us right back to we're all just humanists in the end.
Exactly.
Great. I know we went a little long, but this is an exciting one. A lot of great stories from a lot of folks. So I hope this is useful for people who are. Hopefully there's some tidbits in there. I know that I think we spent most of the time just defining what system software was, and I'm not even sure we got there. But
nope, but close enough, right?
Close enough. But thanks everyone, and we'll talk to you next time.